Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to learn about the sum and difference formula for sine. So let's go ahead and get started. Now, first, we're going to take here a look at a picture of a unit circle. And what it is that a unit circle has what we call special angles on it. These are angles that have been found to be easy to calculate, through experience for various people in mathematics. And so the problem that the sum of difference formula for sine is trying to address is that what if I want to find the exact value of some sort of an angle that is not in the unit circle? In other words, if I want to find the exact value of an angle that is not special, if you will. Now, we talked about how to do this with cosine before, and so in this video we're going to focus on how to do it with sine. It's mostly the same process, but depending on what kind of question you get as you go through your experience with trigonometry, it can make a difference whether you use the sum of difference formula for cosine or for sine. And remember, just to make sure that I'm clear, we are using this formula to find values that are basically not special most of the time in most contexts. So let's go ahead and take a look at the actual equation here, or the actual formula. And so the formula is as follows. You're going to have sine, and you're going to have A. We're going to do plus B for now. And it's going to equal sine of A multiplied by cosine of B. And then we're going to do here plus, let's see here, cosine of A multiplied by sine of B. That's kind of how it works. And now, just to make sure things are clear, in this particular context, A and B are normally special angles. In other words, they're normally some sort of an angle that is on the unit circle. That's what we're doing. And so what we do here is that we combine different special angles to try to find the angle that we're trying to calculate the exact value for. Another thing that I want to mention is that this one is the sum formula. If we want to use the difference formula, instead of having a plus sign in this situation, we have a minus sign in these two places right here. So because they're so similar, I don't think we need to do an example of each one. All right. Now, having said that, let's go to our actual example here. So here's the example we're going to calculate. We need to find the exact value for sine of 15 degrees. Now, if we go back to our unit circle, 15 degrees is probably, probably about right here. About right there, not exactly. Now, obviously, this is not one of our special angles. And so what we need to do now is that we need to figure out, hey, what two angles can I take where when I, for example, find the difference between them, it will equal 15. So what two special angles can I use where when I take the one special angle and subtract it from the other, I'm able to get the value of 15. All right, in other words, A plus B equals 15 degrees is what we're looking. Oh, I'm sorry, not A plus B. We're looking for a difference. Sorry about that. 15 degrees, like that. What two values on the unit circle? And so, I don't know if you can see this, but I'll try to circle it for you. If I take 45 degrees and subtract 30 degrees, I will be able to get 15 degrees. So this is where we take our knowledge of the special angles to find the exact value of an angle that is not special. All right, so I'm going to delete this because I don't need this anymore. Here's what I do. So I got sine of, let's see here, 45 minus 30. These are all degrees. 45 minus 30, that's what we're going to look for here. And so in this situation, we're going to have the following. We're going to have sine of 45 degrees, 45 degrees multiplied by cosine of 30 degrees minus, why is it minus? Because we're looking for a difference. That's why right there. Minus cosine of 45 degrees times, sine of 30 degrees. That's what we have here. That's what we're going to do. Now we need to find the actual XY values, if you will, so you guys know that for cosine it's the X value on the unit circle, for sine it's the Y value. And so when we do that, because I've already looked it up, just to save some time here, sine of 45 degrees is going to be square root of 2 over 2. Cosine of 30 degrees is going to be square root of 3 over 2. Minus cosine of 45 degrees is going to be square root of 2 over 2. And then sine of 30 degrees is going to be 1/2. Now, when I multiply all these things accordingly, square root of 2 times the square root of 3 is going to be square root of 6. And then 2 times 2 is going to be 4. That's the bottom. Minus square root of 2 times 1 is going to be square root of 2 over 4, like that, because 2 times 2 is 4. So we get a final answer of square root of 6 minus square root of 2, all this over 4. That is our final answer. And so the location of this guy here, because this is sine, the Y value will be somewhere about right here, about like that. That's the purpose of that. And so you can see this is not that complicated. But remember that one of the primary purposes of these exact values is to try to deal with angles that I guess are just not special, which is very, very common, you know, when you're doing stuff with trigonometry. So let me kind of go back and recap what we did, and we'll conclude this video. So in this video, we looked at how to calculate the sum and difference formula for sine. And so we began by talking about the unit circle and how you have all these special angles on the unit circle. Special in that it is there. These are particular angles that are easy for calculation. They're very commonly found in different triangles. You know, 60, 45, 60, 30, 90 triangles or whatever, etc. And so they're commonly associated with the unit circle and also with different trigonometry charts, if you will. And so, here's the actual formula for it. You got sine of a plus b, where a and b are both probably special angles, equals sine of a times cosine of b plus cosine of a times sine of b. And so if you have a plus inside the sine, you're going to have a plus out here. If you have a minus sign inside the sine, you're going to have a minus sign out here. It all depends on the situation. And so from that, we went to an actual example and we calculated it, and you can see that the answer here at the bottom. So I hope that this was useful for you and you were able to understand what we were talking about. My name is Darren Thomas. I'm the Director of Educational Research Techniques. Take care.